to Engineer's Workshop. So another project has become a project of necessity. If you can tell by my attire, it's gotten cold here in Virginia. So the failed HVAC motor, which is a fan motor that provides heat for our small barn, got to get that fixed because my son has been doing a lot of work in the shop. So me finishing the boring head extension for the radial arm saw is going to have to wait a bit. Let me get you over to the bench and show you what happened to this little motor and what I plan to do to fix it. So what you're looking at here is what is referred to as a shaded pole motor. Also has a resilient cradle mount. There's kind of a rubber donut at each end, and it sits in a stamped frame with a couple of clamps. And the actual motor casing, the two halves are held with long screws, and the stator core pilots these things together. So to take it apart, you basically just have to take the couple of tie rods out, and then it comes out. So when you look at the inside of one of these, you have a sleeve bearing in the end, and that one is in good shape, but this one up front, I mean, you can see that play, tremendous amount of play. And so that bearing with the spherical front is centered in that front casing, and then is held in place with spring. We've got packing, we've got more oil felt. And then this case here was riveted onto the back side, compressing all this into place. So I drilled out the rivets, and now on the front, the resilient cradle mount also is going to come out. I need to get these remaining rivets out of here. My question was, how do I rebuild this? So my first instinct was bore this out and press in another oilite bushing. Let me show you the one I bought. Bought enough bushings to do all four ends. These are a nice fit. They actually have a few thousandths more clearance than what they will once they're pressed into another piece. So that piece will be bored out. Another bushing will be pressed in. I'll do any cleanup to the ID that I need to fit the shaft, and then we'll reassemble it, substituting teeny tiny screws that I've got to size up to bolt all this back in place. If you look at the stator, you can see where it was hitting. You know, it had gone off center, and then it hits the the rotor hits the stator. And when you put power to this motor right now, all that happens is the magnetism pulls the stator off center or the rotor off center, and it just hums. So I think that once this is held centered correctly, it should just run once again. The way these things work is there's a winding, and I'm not an expert on this, but there's a set of windings, and instead of a starter capacitor or some means to create a phase shift, they have what's called a shading coil. And the shading coil has a weak magnetic field that is somehow rotated relative to the main one, and it gets the thing spinning. That's why these things have like almost no starting torque, but they're okay for fans. And once it's up to speed, it runs on the 60 hertz AC, and that shading coil just kind of sits there and adds a little bit more heat into the motor as it runs, but doesn't really do anything but help it to start. So hopefully we can get this together. I need to make a little bit of a mandrel. Having a spherical end like this, I need to be able to hold this square, and there's not much of a straight cylinder surface here to put in the lathe and say, oh, okay, I'm going to get it square. So I'm going to machine a couple of spacers and a washer and hopefully get this thing to sit squarely on a mandrel. So let's go over to the lathe and get started on it. The idea here was to make a mandrel that can be held on the back end that runs true. So I turned a 60-degree chamfer on that, and I had to put a center into there to let the live center go a little further into that hex broach there. But let me show you how I'm going to hold that bronze bushing. Okay, so I have the little sleeve that I turned to get parallel edges. This washer I kiss ground on both sides so that it's flat and parallel. So basically now this end goes in the lathe and my center will hold this true. And it's just kind of dawning on me now that technically the washer held against the face of the chuck jaws should square it up by itself, right? And we'll see if my center loads in there true. Yeah, touches pretty nice. I think that'll work. So now I just have to remove the mandrel, and my bronze bushing is clamped lightly for boring. We'll see where we're at. Those bushings are not very thick. And definitely have a ways to go. So the OD of the bushing is 564 and a half. 564 and a half. And we are at about 480. We have about 85 thousandths to go. I'm within about 4/1000ths. That's too much of a press. So we will go, there's about 2.5. Feels like it just kind of wants to start, which means it's getting real close. Another 1/1000ths, and that'll leave 1/1000ths press. I kind of overshot it a bit, but I'm lucky in that these two here are kind of tight, so there's still a little bit of interference. These two are basically kind of a line to line. That one's even more of a slip fit than the one that I initially tested. I'm going to go ahead and I'm going to press one of these in from the back so that the front face is flush, and we'll see how the fit is to the shaft. That's a nice fit. Probably put a drop of Loctite on that and see if these two parts can weld themselves together a little bit better. I don't want the bushing spinning in there, but yeah, no real play. Very nice fit. And I'm going to put a couple drops of Loctite. I believe this is 609. Hopefully stick these together. It'll just seep into the pores of the oilite material and between the gap. Don't want to put too much because I do want oil to be able to get to all of the inner surfaces, so I'm going to wipe off any excess. And while we're at it, we'll do this front surface as well. Give that a minute. And I'm reasonably sure those will not move despite my not quite as tight as I like fit. I'm going to take a few measurements next. We do have some spacers on either side of the armature that we can hopefully just subtract from. I'd like to get a little bit of end play in here. And it would be nice if the armature with its spacers were a little bit longer than the gap in between the two halves of the motor shell. So what we're working with is 3068. Sound right? 3068. So the first measurement we're just going to take from the edge of the shell down to the bushing over top of a parallel. And that bushing is going to want to rotate, so we'll probably have to take a few. Two inches 420 minus a parallel that is 1 inch. So 1 inch 420. This side is going to be a little more challenging, because not only do we have the armature we have to get around it, we got a bridge across this and then across the center. So I need another parallel. 3.825. And we got some subtracting to do. Minus 187. Minus the 1 from the parallels. Minus 1,051. So that's minus 2,051. And that is 1.587. So we've got 1.587 plus 1.420 equals 3,007. And our armature was 3,068, so we can remove some of these washers and then get this length a little shorter, which is good. That's what I wanted to do. I think this could stand to have one more washer on the back side to center up the armature better. That looks pretty good. And I think we're going to need to remove at least one of these. Let's try that first. Now we're at 2.980. So that's about 20, that's about 27 thousandths clearance. And I think we're going to have to live with that. Otherwise, we would have to, well, you know what? There's another washer that's a little thinner. I removed that, but I added this one. It's funny, that doesn't seem to change it. That would reduce the end play to about 6 or 7 thousandths. Maybe we should go with that. The holes in the end plates here and the motor casing are at 130, so a screw that's 0.125 would be good for holding these back together. That's a number 5. I'm hoping I can find some number 5s at the local hardware store. Been a while since I've worked with something this small. Ended up with 3mm screws. They did not have any number 5s. These are going to have to go in from the inside. If I can get the spring and all the felts past that little oil tube, which seems to be the biggest obstruction for getting this back together. Well, that was no fun. Okay, I have everything reassembled with screws, nuts on the back side. Now that this is spring-loaded in place, I put the parallel on, rechecked this dimension, got maybe about an 8 thousandths difference. So I set up the armature. Best I could do is 30 thousandths clearance, and every shim I have left over is thicker than that, so that's what we're going to go with. Get a little bit of oil on this and get it reassembled. Spins freely, that's a good sign. Feels like a lot of play. I wonder if I can just take it back apart and shove one of those washers in there. All right, moment of truth. I did reduce the end play, maybe 10-20 thousandths. Good enough. Put it in service. Well, here we have everything back up and running. The repaired unit is on the left. This one's still in decent shape, the motor, but I believe the fan was getting kind of wobbly. So we're going to just run with it hot wired for now, turn it off at the breaker, and get some heat into this barn. Oh yeah, we're going good. And those logs were wet just a minute ago when I put them in, so everything's catching pretty good. Well, that's it from the little barn. Got the heat going. It is warming up rapidly in here. The little radiator that we had in the back corner just wasn't enough to pull the heat out of the boiler as fast as it could generate it. So that fan unit, I think that's good for probably about 200 to 300,000 BTUs at the water temperature that's going through it. So it really does a good job of heating this place up. So back on the project for the boring head extension next, now that I got that motor taken care of for him. Thank you for this little brief project diversion from Engineers Workshop. So until next time, as always, stay safe.